Hello and a very warm welcome. Welcome to Weekly Current Affairs. My name is Madhusudan Reddy and let's begin with today's session. As you all know, this is a weekly current affairs series and we'll be covering up those articles that have been figured out in various newspapers in the past 1 week, and every day we come up with one particular subject, and Saturday we cover up those topics which have been missed out or which have been very much important and do not fit into any other subjects, right? So today's first article we'll be taking up with respect to the 2G ethanol and its importance, along with the sugarcane as an industry, how it has changed over a period of time, and then we'll venture into the various aspects of ethanol linking up with food security, ethanol linking up with the automobile industry, ethanol and also linking up with various other byproducts and methodologies. After that, we'll now go into the details of the Arctic melting as well, and also the Godawari river, which has been in news for quite some time because of the overflooding, right? So let's start with our first article. This is our first article, which you can see it on the screen here. It says that 2G ethanol plant, that is Hali mein, in the recent times, last around 10 to 15 odd days back, the Prime Minister of India has inaugurated one of the largest till date 2G ethanol plant. See, now you have seen this 2G is nothing relevant to the second generation, that means the spectrum of your telecom. It is second generation of ethanol production, right? So in the recent times this has been inaugurated. Now in this context, there is a program that is Government of India's program, which is called E20 program. We'll now be taking up what is E20 program, what is the role of sugarcane in it, and also we'll link it up with various aspects, right? So firstly, the Government of India has come up with one of its visionary aspects in the recent times to blend ethanol with petrol. Ethanol plus petrol. That means 20% of the total petrol that you use should be blended with ethanol, right? So if you have been into the fuel station, if you are using 10 liters of petrol, it is an indication that out of that 2 liters will be now ethanol, which is blended with it. Now why do we have to blend this ethanol with petrol? That's the question. So we'll be addressing this, but before that you have to know that India has already achieved the E10 targets. Now what is this E10 target? E10 target is nothing but ethanol blending with petrol with respect to 10%, right? Today India has already achieved this, and we are now heading towards blending of ethanol of E20 by the year 2025, right? So firstly, what are the uses of ethanol and how exactly ethanol is produced? You have to know that ethanol is one of the byproduct of the sugarcane. The crop which you see, sugarcane, while converting sugar cane into sugar, one of a byproduct you will get, that is your ethanol. Along with ethanol, there are many other byproducts, but the significance of ethanol is that it is considered to be a clean fuel. Now what do you mean by clean fuel? Petrol, diesel, these are not considered to be the cleanest fuels. The cleanest fuels are those fuels when burnt, you take up 1 glass full of fuel and burn it, this should not give you any kind of carbon dioxide into the atmosphere, then it is called as a clean fuel, right? So the petrol, diesel, whatever you burn, the soot that comes out from the silencers is nothing but they are completely unburnt fuel that is left over in the form of carbon material, right? Those are those fuels which burn their 100% of carbon within it is called clean fuel. So ethanol is one such type of your clean fuel. Here you have to understand that ethanol only do not give out carbon dioxide, but when it is burnt, it still gives NOx and SOx. Okay? Nitrous oxide and sulfur oxides, they will be produced when ethanol is burnt. Now ethanol when burnt, it will not give out carbon dioxide. Now we have to understand the significance of this carbon dioxide. See, carbon dioxide is one of the greenhouse gases, and these greenhouse gases, they'll have a tendency, they will be transparent to the incoming solar radiations and will be opaque to the outgoing terrestrial radiations. The atmosphere which you see is generally heated by the heat that is radiated back from the earth. So now these heats are being captured by the carbon dioxide, right? So if at all you increase the carbon dioxide concentration into the atmosphere gets heated. Now one of the targets to reduce this carbon dioxide from the fuel burning is through adapting to the ethanol. That means you take 10 liters of ethanol and blend 90 liters of fuel. That means overall it will add to the 100 liters. This is how it is blended, right? And we have already achieved this target. By this means, from every now on, you should know that the petrol that you use, it has 10% of ethanol. Now you might have a question, if I am using ethanol or if I am using any other fuel, is my vehicle safe? Yes, we will also be addressing this question. Before that, one should, as an aspirant, know that processing and the growing conditions of the sugarcane is also very much important for our examination, right? So sugarcane growing conditions bhi aapko janna chahiye. Along with that, how exactly, at what stage the ethanol comes out. Before that, first let's deal with the sugarcane as a crop and the problems in the sugarcane industry, and then we'll again come to the ethanol and understand its dimensions, right? So firstly, sugarcane as a crop. See, sugarcane is one of the cash crops. And what do you mean by cash crops? If you know, please comment in the comment section. See, cash crops are those crops which give you good amount of yield, very good yield you will get, but the gestation period for the growing of these plants is generally large. They can be plantation crops, they can be cash crops, they give huge outputs, but you need to wait for some time. For example, from the sowing time to growing, harvesting time of the sugarcane, on an average it will take somewhere around 360 days, and sometimes it will go up to 12 months se lekar 18 months. Now that depends on what type of sugarcane are you growing. So imagine you are a farmer, and not every farmer can grow this sugarcane, right? Not every farmer can grow this sugarcane. Today you have grown this sugarcane and it takes somewhere around 12 to 18 months. That means until 12 to 18 months in this period, the farmer is not going to get any kind of income. So the small and marginal farmers in India, can they survive a period where they do not have an income for 1 year? Usually it is no. So only big players of agriculture, they can adapt to these kind of cropping. That means the game of ethanol is also based on the game of sugarcane. So if you sugarcane production agar impact ho gaya, it will also impact the production of ethanol. But today we are discussing the second generation of ethanol, right? Now second generation of ethanol means it is not the ethanol that has been bought or a byproduct of the sugarcane. Now ethanol can also be bought out or processed, and it can be extracted from other products also. When it is extracted from either woody substances or rice starch or even your corn starch, these are some of the examples where your second generation of biofuels or second generation of ethanol is considered, right? So this is about sugarcane. And one more thing we have to understand with respect to sugarcane is that sugarcane is one of the volatile crop which can be grown by the farmers. Now what do you mean by volatile crop? See, the sugarcane as an industry has some problems. Sugarcane as an industry has problems. What are these problems? These problems are that if at all the sugarcane crop, after 18 months or 12 to 18 months of time period they have waited, they need an industry that need to be milled, and that industry need to be located very near to that place, very near to the crop growing area, because a sugarcane after it's harvested, it need to be milled within 24 hours. If it is not milled within 24 hours, the issue is that the quantity or the quality of the sugar within the sugarcane, that will reduce by at least 40%, around 30 to 40% it will drop. That means 30% of the total output of the total sugar cane, it will be reduced. For that they need good amount of area and good tie-ups with the industries, right? Now let's quickly give a glimpse of the growing of the sugarcane. Initially you will grow the sugarcane. After that, the processing of the sugarcane involves too many methodologies. So let's quickly deal with this. What exactly is the process and where exactly is the ethanol that will be extracted, right? See, let me show you. Look here. Here, imagine this is your raw sugar cane. ठीक है, यहाँ पे आपको near about 12 to 18 months it will take time. From here you have to take to the industry and then mill it within how much time? Within 24 hours. If you don't mill this within 24 hours, the issue is that the calorific value or the output of the sugar cane will drop, because sugar has a tendency to do volatile, right? Now after this, the byproducts of sugarcane is nothing but when you mill that sugarcane, the output or the product which is left over, it is called as bagasse, right? Now that bagasse is separated, that can also be used as a source for other materials, and it can be a raw material for other manufacturing units such as paper and all can also be extracted from there. Now this bagasse goes into the juices, the bagasse is separated and the juice is extracted, the juice is subjected to crystallization process, and that crystallization process they'll put it into a big reactors where they will be rotating, so that finally another product comes out, that is your molasses. Okay, molasses is nothing but a dark color substance that you will get to see in the processing of sugarcane. Now let's go into little detail and see these are the areas where preliminary questions can be asked, right? So sugarcane, when you take out and then you extract the juice out of it, the juice need to be filtered and then small crystals will be formed, right? Now in that crystals, when they are subjected to before the crystallization process, if they are centrifuge is nothing but you put them into one of the bioreactor and start to rotate it. Now the rotation will be of a huge speeds. In that speeds they'll tend to, the sugarcane before crystallization, the juice will tend to get thickened. Now that thickened material is nothing but your molasses. Okay, molasses looks dark brownish in color, little black in color, that is your product. Now from this molasses you can get some other byproducts, and one such byproduct is your ethanol. In case you can also get lactic acid भी मिलता है इसमें, ठीक है, जो curd में आपको मिलता है, that is also lactic acid you can also get to see. Cells की अंदर proteins, that is also very important component which is used in the medicinal properties, medicines के लिए use किया जाता है ये. And also it is the glycerin materials, glycerin is nothing but the sticky substance which you see, that is also extracted from the molasses as a byproduct only, ठीक है. So sugarcane as an industry, it has so many uses. Now from bagasse, that is the leftover product of the sugarcane, from that bagasse you can generate electricity, you can also make papers, you can also make compost, and usually there are fungus that are grown various parts of the world. Fungus ke liye they need some sugar, finest sugars which are sweet. That sweet is generally, natural sweet is found in the bagasse. Now if you start to give bagasse and start to grow the fungus, and always remember this fungus is not always harmful. There is good fungus, there is bad fungus. So the best good funguses are grown using this bagasses, where this bagasse will be used in the food, as a food for that fungus. That fungus will be grown on these bagasses, right? So I hope now you got it, that ethanol is one of the byproduct which is extracted from molasses, and this molasses is one of the byproduct for the sugar cane. So today we are using this ethanol to blend with petrol. Okay, we are using this ethanol to blend with petrol. That means out of every 1 liter of petrol, you'll now be blending 10% of the total petrol, right? Okay, now let's go a little further and also understand the difference between second generation of ethanol with respect to second generation of biofuel. Now there is a fundamental difference in this. Please do not confuse. These kind of things, questions can be asked in your preliminary examination. Now let us quickly see the difference between second generation of ethanol and second generation of biofuel. See here, the slide which talks about here is the second generation of biofuel. Now second generation of biofuel includes, suppose if at all the biofuel is obtained from the crops, that is your first generation of biofuel. Now other than crops, woody substances, straws, grass, waste जो होगा, अगर if you are extracting the fuel from that, then it is called as a second generation non-edible biofuel. That means they are not meant for edible purposes, means we cannot eat them in the raw formats, but these crops, they can be eaten by individuals and it is an edible component. In simple terms, this is not used for the food purposes. If you generate it, then it is considered to be second generation biofuel. Now coming to the third generation of biofuels, where we use algae, microorganisms. If at all you use them to generate a fuel, that is biofuel, then it is called as third generation. And lastly, fourth generation is nothing but using genetical modifications, or else if you convert solar into fuel today, which we are doing it, it is a fourth generation of energy we are getting it. right? We can also engineer this algae. The algae that you get, you can amplify this algae growth. Amplify means you can make it bigger in size and then get more output. So these kind of things are nothing but your fourth generation. Now coming to the biofuel of the second generation ethanol. Okay. As I have already told you, ethanol is extracted from which product? Mostly ethanol is extracted from the sugarcane, but you should also understand that ethanol can also be extracted from rice. ये stubble है ना, rice stubble. This is your rice के stubble से भी extract किया जा सकता है. Wheat straw, after the wheat is taken, the product of the final product is taken, the rest over residues, that is called wheat straw. The bagasse, anyways, you know, corn cobs as well as woody biomass. Woody biomass means the leftover parts of the wood which is not in an edible composition, right? Now if biofuel or the now either from rice straw, wheat straw, bagasse, or the products that you see it on the screen, now these are called as second generation ethanol. Okay. So second generation ethanol. By now you should be in a position to understand the inauguration that has happened in the last 15 days is based on the second generation. That means these are the products that have been used. Now here you have to understand that this is rice stubble and this is wheat straw. If you look into the origin and the locations of the origins of the pollutions of Delhi every year, the major reasons here are nothing but the straw and the stubble that has been unutilized, right? So now this second generation ethanol plant will be using the materials that have been left over by the farmers. Now this has huge impact, a positive impact on the farmer, as also a positive impact on the environment. How? See, earlier what the farmer used to do, farmer in the ethanol component, let's take up the environmental angle. See, in the environment angle, earlier the farmer who used to burn the stubble, okay, of the rice. Now this stubbling of burning of the fuel is generally impacting which cities? Delhi and in and around areas. Now the farmer will get an income for giving, instead of burning, if you give it to the 2G ethanol plant. Okay, farmer is getting some kind of income. Now if this income will also augment the farmer, as well as earlier the burning material which has emitted the CO2 and other NOx and SOx materials which would have impacted the Delhi as a polluted area will now no longer be utilized. And in spite of this, in addition to this, you have to understand that on an average every year there are 67,500 vehicles. आज जितने second generation of ethanol plants है, the second generation of ethanol will augment the reduction in the carbon dioxide that has emitted by almost equivalent to 67,500 vehicles. Indirectly, it is meant to say that around 67,500 vehicles that are plying in the nearby areas, that number can be reduced in terms of carbon if you calculate. Now this is a net overall positive for most of them. Okay? It is a net overall positive for all of the stakeholders. Look at the stakeholders here. One, farmer is a stakeholder. Second, environment is a stakeholder. Thirdly, there is India at a large. India in the recent times, if you know that India went into the Glasgow and said that we are going to go for net zero emissions. Now if you understand the concept of net zero, India went in, said that by 2070 we are going to be the net zero. Now what do you mean by net zero? In simple terms, whatever the amount of carbon dioxide that you are going to generate, you are also going to sink it the same carbon dioxide by the year 2070 annually, right? Now these kind of large commitments if India has, it is also the duty of India to look forward for renewable energies and clean environment. If we do not meet these targets, it is an unrealistic target which we thought, but now today if you see, these kind of programs will enhance and augment the 2070 net zero targets. ठीक है? I hope you understood that. Now, coming to the industry of automobile, ethanol blending, if you link it up with the automobile industry, now is it a positive activity or is it a negative activity for the ethanol blending if it happens to the automobile industry? See, every year there are lakhs and lakhs of vehicles that are coming onto the roads, right? If these number of vehicles that are plying onto the roads, now new carbon dioxide emissions will increase, the usage of the fuel will also increase. Now if the government of India has now gone for E10, tomorrow E20 is very realistic, we can see that by increasing the production of the straw and the maize and other products, right? Now here you have to question yourself, are these vehicles competent enough to handle an additional fuel other than petrol and diesel, which initially these vehicles have been meant for fueling the diesel and petrol, right? Now you have to understand that not all vehicles are capable to handle the E10 and E20 petrol blending with ethanol. So in this case, what about the vehicles that have already been bought by individuals? For example, I as an individual or you as an individual have bought a vehicle 2 to 3 months before. Now would you be willing to sell off your vehicle where the E20 blending will be a realized target by the year 2023, and all the vehicles it is said that they should comply with the ethanol blending 2020 petrol complied vehicles, right? Now in this condition, it is one of the biggest negative enhancements for the automobile industry. ठीक है? इसमें और भी challenges है. Challenges are like handhold vendor to develop ethanol compatible parts. Abhi all the automobile industry should now go for developing new kind of parts, new technologies that will increase the cost of the vehicle, so which will indirectly have an impact on the economy as well, right? Now optimization for higher ethanol blends, you need to have good technologies where you can blend ethanol at a higher rate. And lastly, if you look into the challenges to the manufacturers conduct also the durability of the engines as well as field trials before going for E20. ठीक है? इनका मतलब ये है E20 vehicles first they need to be tried and tested, and it is said that by the year 2023 of April 1st से all the vehicles will have to comply with E20 norms. Now in this, as an individual, one has to understand that every part that is used in the fuel technology that need to comply with E20. That means the plastics, the rubbers, the steels, they should be capable of absorbing the petrol that is blended with ethanol. So today, not all vehicles do not have that capability and capacity. That means a person who has bought a vehicle today, he or she won't be in a willing position to change or switch their vehicle to the next technology. ठीक है? It takes at least around 10 odd years for an individual or normal individual to shift their vehicle. Now this kind of activity might have a negative impact on the automobile. But recently there is a report. The report says that the alternative fuels that are available to the mankind today, you already know that most of the vehicles that we use, either they are of the fuel that is used is either because of the ethanol, natural gas, or the petrol diesel that we generally use, or else we use natural gas, we use ethanol, we also use electricity, and we are now heading towards hydrogen CNG gas. So let us do a small cost benefit analysis here. Which kind of fuel has more likely the realistic targets and the realistic aspects if at all India has to go forward in adapting to these? Now let's look from the automobile industry side. See, as an automobile industry, if you have to get the hydrogen as a fuel for your vehicles, what you have to do? You have to develop this technology. Today, hydrogen technology is very, very costly. It is way beyond estimation the cost goes. That means your vehicles will have to comply with these fuels and they will also be very costly. EV is already a reality, right? EV is already a reality, and at the same time, ethanol can be a reality in the near future. Natural gas, yes, it is always there as an alternative fuel, but natural gas ke liye we should always be dependent upon those countries which has oil with them, right? India is an agrarian country. India has huge population. Can't we convert them into an asset? Let's see it here. And India has vast land masses as well. So, for example, if you see, you take 1 hectare of land, okay, 1 hectare of land, and you start to plant a solar plant, okay, and you take 1 hectare of crop, okay. See, from the crop itself, we are estimated that we are going to get the ethanol. Now, from this, the solar energy that you generate outward, the 1 hectare से जितना solar energy आप generate करते हो, now equivalently you need 187 hectares of land of crop to meet the same energy requirements that are given by 1 hectare of solar energy, right? So let me repeat again. Suppose you take 1 hectare of land and you plant solar plants here. That means solar panels and all, you put it and start to generate electricity. Now this electricity will be used by the EV vehicles, right? So the number of kilometers that are run by these vehicles, if you take into consideration from the 1 hectare, these vehicles will definitely need around 187 hectares of crop to run with the same fuel, right? Now under these conditions, India has large populations, we have huge population, and in this population, along with that, our land holding capacity per unit area with respect to population, it is very, very low. 85% of total Indian farmers, near about 85% of the total Indian farmers are small and marginal farmers. Now under this consideration, can we go for this kind of cropping system where we can generate ethanol and then give it to the fuel? So it is generally said that it is the same food crop that is going into your plates, and it is also the same food crops if they are going into the fuels. Don't you think there is a mismatch? Yes, there is a mismatch. The mismatch is in such a way that for automobile industries, the adoption with respect to this particular methods or going for the automobile industry is going for the development of the ethanol, it is at a cheaper rate. If they have to convert their vehicles instead of ethanol into electricity, it is also a huge cost. Now hydrogen CNG, it is beyond our limits, and natural gas and all, they are already in action. So for the automobile industry, ethanol seems to be one of the finest options in the near future. But the targets, if the automobile industries have to meet, on the other hand, the issue here is they should also, our farming community should produce this equivalent amount of crops. And let's look from the food security angle. Okay, let us take the same thing from food security angle. Food security mein, India is a food secured nation, everyone knows that, but are we in a position to grow such huge number of crops just for giving the ethanol to blend their crops, to extract that ethanol? Here you have to understand that maize, rice, today the government of India is not in a position to buy the entire crop that has been grown by us. But at the same time, if you go and see in the last 122 odd years, March has been the highest temperature, because of which we ought to stop our exports to Egypt and keep our all wheat with India. Now these kind of situations can happen any point of time. So if you target the ethanol blending, you should also target the food security in tandem. If you do not target the food security and have a calculated methodologies, your ethanol blending projects can also get derailed. So under these considerations, the Food Security Act and the ethanol blending program, they should go in tandem, not just giving the unrealistic targets of 2070 net zero emissions. Of course, the automobile industry should definitely contribute to this. Now, for an automobile industry, instead of going for a hydrogen fuels, they will always be happy to go for a fuel generated from the ethanol blending, and they can easily adapt because the changes are very little and the automobile industry can survive. But let's look from the farmer side. Here the farmer, they have to grow 8-fold times of the crops that they are growing today. And that is quite impossible for the India as a nation, because it is India where the food crops, where these food crops are also meant for the food security of the program. If you start to divert these food crops into other areas of generating the bioethanol or the biofuels, don't you think that this food security program will be impacted? Yes, there are chances. Now, one of our reports says that to meet the demands, at least eightfold times of the grains today they need to be generated, and also effective utilization of the resources that are generated from the stubble crops and pooling of the people is very much important. Here the role of cooperative societies comes into picture. Only then it is said the reality of the E20 by the 2023 it is going to be real, right? Now these are some of the challenges that have been involved. Along with this, one last component which you have to deal is that in the recent times the sugarcane industry is also moving from North India to South India. If at all you know the answer, please comment in the comment section why sugarcane industries are moving from North India to South India, in spite of there are more sugar industries that are located in the northern part of India. Okay. And also from the preliminary examination point of view, you should be knowing the refineries that are located with respect to the 2G ethanol blending programs. Today we only have one 2G ethanol blending program, but it is said that there are 12 blending ethanol programs which are going to come. The refineries are going to be set up. Now you should, from the preliminary point, as and when the new ethanol plants of 2G are set up, or if they are into action, you need to remember that. And let's quickly look into the roles of the role of sugarcane industries moving from North India to South India. Okay. Here you have to understand that why are they moving from North India to South India? One, I told you sugarcane as a crop, it needs 24 hours to get into the mill, right? If it has gone into the mill, it need to be milled out and the money need to be paid back to the farmer. Now imagine there are lakhs of acres that are nearby this 1 or 2 or 10 or industries, and all these industries, they do not have the potential to pay as and when they have been milled. So under that conditions, the mill owners, what they do is they make a partial payment, and then the rest of the payment will be paid to the farmers only when the entire product is sold into the market. The farmer has to wait, right? Now in these conditions, all the farmers, they need to find a market first. They need to find a market. They need to find a market first in order to mill it and immediately get to the market, right? If at all the milling process is delayed, okay, instead of taking 24 hours, maybe the mill has taken around 4 odd days or 5 odd days. In the due time, the output of the sugarcane will come down. That sugarcane will start to shrink. The juices will be volatile in nature. So under that conditions, the output will be less. So before even getting milled, if the output is low, don't you think that the farmer would be in a derailed situation? Yes. So here you have to understand that the cooperative societies plays a major role. Now what is the role of these cooperative societies? Cooperative societies, what they do is, firstly they will form as a farmer producing organizations. From then they will start to find the market first, and they will have a dealing with the industries. They will take the time from the industries and they will be sowing in such a way. Not every farmer has to sow their crop on the same day. What they have to do is, few farmers need to sow their crop today, and few other farmers tomorrow, and few other farmers little later. Like that, the industry will also have in tandem crop coming from the sugarcane crops, right? So that the industry's capabilities can also be met, industry's capacities can be milled at their best, right? Instead of the crop being left over, right? So for this, cooperative societies are considered to be one of the major factors which will play in terms of setting up an sugarcane industry. So these cooperative societies are very much stronger in the southern India, and they are not stronger in the northern India. That's the reason why the ethanol blending program, if you see, it will be a successful in the southern India rather than the north India, right? Now second point is that the crushing season is longer in the peninsular India, as it does not get very hot in the summers compared to the north. So this is also one of the climatic factor. And another factor is that the sucrose content of the sugarcane jo hoga, when it is grown in the higher in the peninsular India, it has more amount of sugar that can be extracted from the rather than a plain area, right? These are some of the reasons why sugarcane industries are shifting from North India to South India, and this is about the article in detail. If you look into, there is one more component that we have to deal with this article, is that the water composition and the water capabilities of the ethanol blending program. See, if at all you are wasting 1 kg of rice or one meal of your rice, it is an indication. If you measure that one meal of your rice through water, okay, if this one meal of rice, if you have to compare it with the water that have been used for the growing of rice is very, very huge, or it is more than thousands of liters to produce 1 kg of rice. Similarly, the kind of product such as sugarcane, to produce that ethanol, how much amount of water is needed in terms of its growing? See, you should know that a ton of sugarcane gives you 100 kgs of sugar and 70 liters of ethanol. When 100 kgs of sugar and a 70 liters of ethanol is obtained from the sugarcane. But if at all, if you look it from the water perspective, to generate 1 liter of ethanol, somewhere around 2800 odd liters of water is required. That means if you start to grow the sugarcane more or water intensive crops more, and to generate ethanol as a byproduct, and you wanted to use this ethanol to blend the petrol, then your water consumption in that area will also increase. So this can lead to drought like situations also if it is not managed well, right? So in this program, overall holistically, one has to look from the environmental angle. We have to take into the stakeholders of farmer and the automobile industry, the government, the net zero and the environmental angle, along with the water. Here you have got somewhere around 6 to 7 odd points where you can delve into this particular article, right? If you are in a position to deliver at least 5 of these points, I think as a student, the role is, as a student, you are a successful candidate, right? Now coming to the next article. So in the Hindu newspaper, there is an article that has been given, what is causing Arctic warming? Okay, what is causing the Arctic warming? In the last week also I have discussed a little bit about the Arctic warming, how exactly is Arctic going on, and I have also told you the difference between an ice sheet and also about the ice cap, right? Ice sheet and ice caps. So once quickly revise what we have learned and then we'll move into the other areas. What exactly is this article talking? इसमें कुछ ऐसी words use किया गया था. The potential of these words in the examination is very, very high. They have said that Arctic potential, Antarctic potential or the polar potentials of the earth, they have multiplied over a period of time, right? So firstly, let us try to understand the difference between what is Arctic and Antarctic before we get into these articles. See, Arctic and Antarctic, the images will tell you how exactly are they different from. If you see the Arctic area, it is small in size and it has continents around, right? These are your continents, and this is small as compared to the Antarctic area and a continent surrounded area. But once come and look onto the Antarctic, it is a continent, a major land mass and a major area which is surrounded by seas. Okay. So this is the first point one has to understand. You have to understand one more component, that the specific heat fundamentals. See, to heat 1 liter of water, you need more amount of heat. At the same time, if you want to heat that 1 kg of land mass, you need less amount of heat. That is called specific heat. Under that considerations, you have to know that land gets heated quickly and cools quickly, and ice or water, they gets heated slowly and cools slowly. Okay. Similarly, look here, the water that are present in and around, it will take some time to heat, right? On the other side, you look into the continent here, they'll heat quickly and they'll cool quickly. Because of that, you will have some kind of atmospheric changes that you will see above the Arctic region and also the Antarctic region. Now this is a very cold region. This is also a cold region. Arctic is also a cold region, no doubt. But the coldest place in the entire universe entire world is in the Antarctic. So apart from this, let us also quickly look into some other differences, what exactly, how Antarctica is different from Arctic, and then we'll move into. See, look here, this is the size of Antarctica and this is the size of Arctic. Now in the Arctic, let's take a Greenland. See, the Everest height and the Tibetan plateau, if you see, on an average it is around 4.5 meters, the Everest height is 8,000 meters, and everyone knows that as you go higher into the atmosphere, what happens is that the temperatures comes down and then you'll have the lapse rate falling. Overall, you'll have a cold environment. Now just imagine this kind of environment is also present in the poles, and the height is also equivalent to somewhere around 3,500 meters. Now what is the temperatures that are going to be sustained there, or what are the temperatures that you will see there, right? See, Antarctica is a plateau firstly, ठीक है, Antarctica एक plateau है, plateau मतलब an elevated land, this is your plateau. Now upon this plateau there is a big ice, now this is your Antarctica. Now the height of Antarctica, if you see on an average, it will have 2,900 meters above sea level, that means this is all your sea and this is your ocean. If you look into the Arctic, here the landmass is small, this is not a plateau, more or less like a semi-plain area, except the Greenland, it is also covered by land on either sides, okay, land and land. This is your Arctic. Now there is a difference, in this difference is that the height, at this height the temperatures are more, the erosions will be more, the depositions will also be more in the lower regions. Now the albedo will also be more. Albedo means, let's see, imagine there are sun rays that are falling on this land, okay, as the height of the Arctic is less. If you see, the height of the Arctic is less but the height of the Antarctica is more. Now if at all the sun's rays has to come and fall, will they reach the Arctic first or will they reach the Antarctica first? The sun's rays will reach Arctic first, and if at all the sun's rays comes and falls onto this Antarctica or Arctic, snow has a tendency to reflect back the rays. Now the reflection is more than 90%. This reflection component is called as albedo. Okay? This reflection component is called as albedo, right? Now just imagine, if the incoming solar radiations, this is the solar radiations, incoming solar radiations are nothing but your sunlight. Now this sunlight, when it is coming onto the surface and hitting the polar glaciers and reflecting back, that means not much of heat is taken by these glaciers, right, this area. But now imagine you start to melt this, you start to melt these glaciers. Now imagine under the glaciers there are some rocks, ठीक है, काफी बड़ा rocks. Now imagine the area to be thousands of kilometers where the rocks have been exposed to the over a period of time because of continuous sunlight, and albedo has increased and the global atmospheric temperatures are also increased, right? Now same is the principle that can be applicable even for Arctic and even for Antarctica also. Now here the heat is amplified. Amplified means, imagine this year if the temperature is risen by 0.5 degrees Celsius, next year it will be 0.10 degrees Celsius, and the next year it will be 20, and the next year it will be 40, and the next year it will be 80. 80 means 0.80 I am talking about, right? Now this is called exponential growth of temperatures you will get to see in Arctic and Antarctica. Why are they exponentially growing the temperatures? What is the reason behind it? Can you name? Can you tell me how exactly are they happening? Can you comment in the comment section? See, before I explain any further, once let's go back to the article and see what exactly is the article talking about. Here the article says that, this is the article and it exclusively talks about the reasons. The reasons it says is very much interesting. Let us read this one small sentence here. Among the many global warming driven causes for this amplification, the ice albedo, look here, it is ice albedo number 1, feedback, lapse rate feedback, water vapor feedback and ocean heat transport feedback. Now it has talked about 4 different reasons why exactly Arctic and Antarctic is melting at a faster rate. And if you see the Arctic articles here, the heading of the article says, why is the Greenland ice sheet melting at an alarming rate? How is it affecting the monsoons? What is causing Arctic warming? See, warming is not just Arctic also, this Antarctic warming is also there, but this article is talking about Arctic warming. Now the principle of heating or the principle of warming either of Arctic or Antarctica is both the same. Now let us try to understand the exact reasons why exactly are they melting at a greater rate. Now that greater rate of melting at an exponential point is nothing but your Arctic amplification or polar amplification. So these kind of points can be easily asked in the examination. So firstly let's read this small paragraph and then we'll move ahead. See, while changes are witnessed across the planet, that means climate change is witnessed across the planet, it is not to one, it is to everyone. Now, any change in the surface air temperature and the net radiation balance tend to produce larger changes at the north and south pole. So, any changes in the global atmospheric temperatures, the change will be greater at the north pole and the south pole. Now, why is this change greater and what is it called? Now, this phenomena is known as polar amplification. Okay? Polar amplification matlab, if you start to increase the temperature by 1 degree Celsius of the earth, then at the poles, north pole and south pole, the temperatures are risen by at least 3 to 5 degrees Celsius. It is said in the Arctic it is increased by 8-fold times, right? So, for that, this kind of phenomena is known as polar amplification. If it is happening in the Arctic area, it is called as Arctic amplification. If it is happening in the Antarctic area, it is happening in the Antarctic amplification. And the reasons that article has mentioned here is that it is said it has highest albedo feedback, lapse rate feedback, and also water vapor feedback and ocean heat transport feedback. Now, let's try to understand what are these feedbacks. Feedbacks are nothing but, if at all, the normal rate has been changed over a period of time due to abnormal conditions you see in the atmosphere, that is called your feedback, right? Now, let's try to understand one by one reason of this, because these kind of articles will have high chances in the examination. So, before that, let me show you how exactly a glacier looks and what is a ice sheet and an ice shelf. As I have already dealt in detail explanation of these concepts in the previous classes, now previous videos of Saturday. Now, I will only give you a brief understanding. Now, this is your Antarctica. Average height of Antarctica is 4,000 meters. Average height is around 3,000 odd meters. The highest peak is somewhere around 4,000 meters above the sea level, right? Now, ice sheet, if you see, the size of the ice sheet is very, very small. The size of the Antarctica is very, very big. Even the height of the Greenland also, the highest peak is around 3,000 meters. So, the heights are very, very tall. Now, just imagine this is the height, this height is more than Shimla's height, more than Dharamshala's height. This is having more height as almost at an equivalent height of Leh Ladakh. Okay? At that height they are located, and that too in the polar regions. Imagine the chills that one has there, right? And let's quickly delve into the reasons. Let's move ahead. Now, I hope everyone understand what exactly is albedo, and also you have to know the tendencies of the glacier. Now, imagine this is your Antarctica. See, under the Antarctica there are many rocks that are left over. It is not a plain land. This is your Antarctica, ye maan lo, there is sea, and this is your Arctic, and you have land around. So, under the glacier, a glacier is covering so many rocks, big boulders, big plateaus. And these rocks, they have never been exposed to sunlight in their lifetime, at least for millions of years by now. Over a period of time, the sun's rays and the atmospheric temperature will start to melt this particular area. Now, slowly they will start to expose, slowly this entire region will now be exposed to the sunlight, right? If at all, these rocks, if not the entire area, some part of the rocks have been exposed. That means, imagine this part of area is exposed to sunlight. So, the sun's rays, earlier what used to happen, around 90% of the total sun rays that are coming onto the snow, they have been reflected 90%. But now, as the rocks are exposed, the rocks will be dark in color, and they'll have fossil fuels within it, they'll have methane, they'll have carbon dioxide, which is also being emitted from these rocks. And at the same time, the incoming solar radiation, that is your sun, it will come and it will also heat these rocks. Instead of having 90% of albedo, here it might be reflecting back only 60% or only 50% of the total albedo. Now it will start to take that heat. Earlier it is not taking the heat, the ground is not taking the heat, now it will start to take. And every now and then these rocks, they get heated more and they will start to melt the ice that is in contact. Okay? As they start to melt, instead at a normal area near to the equator, the water is taking some time and it will start to increase its temperature and there will be rainfall. Now here there won't be any kind of rainfall, it will always be snowing if at all it is happening, because the temperatures are minus degrees. Now slowly the temperature increases. Every year the intensity of this increases, because earlier there was ice, now there is no ice that is present, and the amplification, it will be folding at a greater rate. Now the rocks beneath, they will also be opened up right? Because it will start to melt the nearby ice. Now slowly, if this area is opened up, it will start to rise the sea level as well. It will start to rise the sea level. Earlier, if this is the height of the sea, now as the water that has been melted, the rise in the sea level will take place. Okay? This is the normal level of the sea. Now this is the raised level of sea. Now most of the raised level of seas, the transportation of water will come to the various parts of the world because of the global atmospheric and oceanic circulations. So here you need to understand it's an amplification process that is taking place here, that too in the Arctic and Antarctic region, right? The first reason is albedo feedback. Now albedo feedback, in the sense, earlier the albedo is 90%, today you will have an albedo of 50 or 60 odd percent. So this is a feedback, that means there is a reduction in the albedo percentage. This will start to heat the polar areas. If the polar areas are heated, India's monsoon will be impacted, especially if in the Antarctica. In the Arctic, the areas that are lying, the continents that are lying around the Arctic, they will start to, the rise in sea level take place, there will be submergence of the islands, right? Now let's look into the second reason, which is called as the lapse rate feedback. Lapse rate feedback is nothing but, if at all, as you go high into the atmosphere, every year, sorry, for every 1 kilometer, if there is a reduction in temperature, that reduction will be 6.5 degrees Celsius, that is the normal lapse rate. 1 kilometer you go into the atmosphere, 6.5 degrees Celsius will reduce temperature. So imagine, let's take the conditions that are present before, when there is ice. Okay, let me redraw it. So this is the normal condition where the incoming solar radiations are coming and hitting back. 90% of albedo is there. Now this is an area where the rocks are exposed and the incoming solar radiations are coming and it is absorbed. It is, that means this particular area will have difference in temperature. Now this area, it will be cold in temperature. As you go higher, it will get more colder, right? Now for every 1 kilometer, the lapse rate is going to decrease. Here also it is going to decrease, but it's a failed lapse rate which is present in that area. So this is called as lapse rate feedback. Lapse rate feedback means 1 kilometer height, 6.5 degrees need to be reduced. But as you go higher, now here the lapse rate changes are generally seen. Because of this lapse rate change, there can be rainfall, there can be instability, there can be cloudiness. So some kind of changes you will get to see in the Arctic region, right? Now the transportation of heat is not unique here. Transportation of heat is also talked about in this article. Let's go back and see what exactly this article talking about. See, water vapor feedback and ocean heat transport. You have to understand that the entire earth keeps on transporting its heat either through the process of conduction, convection or radiation, right? Conduction, convection and radiation process ke through heat is transferred. The heat is also transferred even in the oceans. Cold water from the poles will come to the equator and equator water will always go to the poles because there is coldness and the heatness that is exchanged through the conduction processes, right? So now there will be disturbances in the ocean atmospheric circulation, in the water as well and in the atmosphere as well. Because of that, the Arctic melting will also increase more. The amplification will be more, right? Clear? Now from this, apart from the causes, you need to understand about a report and also from the preliminary examination point of view. That is special report on the ocean and cryosphere in the changing climate in 2019. So this is the first report that came up and said that, okay, there is Arctic heating, it is amplifying at a greater rate, and later one of the report came, that is Arctic monitoring and assessment program. इन्होंने एक और report दिया था. इस report में ये कहा गया था that Arctic melting is at a greater rate, right? And it is one such agency which is working on the Arctic and Antarctic areas, and they give assessment programs, कितना melting हो रहा है, कितना और हो सकता है, these kind of things. And these assessment reports are also taken into consideration by IPCC. IPCC will give its assessment report, AR6 report, right? So these are some of the preliminary facts one has to understand. Along with this, you need to also know about another equipment or the agency which India has in the Arctic area, that is your IND-ARC. Okay? Just a minute, let me show you. Okay, I think this has already been asked in the examination. What is IND-ARC? IND-ARC एक ऐसी प्रोग्राम है इंडिया का, अंडर वाटर सी वाटर में वी हैव placed our equipments in the Svalbard area in the North Pole region to understand the changing dynamics of the North Pole, so that if you study the North Pole, there are similar kind of climates you also have in the Himalayan region. So melting of Himalayas can also be understood. So that is the reason why India has its stake even in the North Pole area, where we have our own research stations that we have discussed in the previous classes as well, right? So IND-ARC, IND-ARC is once India's first moved underwater observatory in the Kingsford Fjord, Svalbard. मतलब ये प्लेस आपको याद रखने की ज़रूरत नहीं है, but still you need to know that what exactly is IND-ARC. IND-ARC means it is an underwater research station है, observatory है. How exactly it is happening. Now apart from this, you should also know another reason why exactly the melting of the glaciers is happening, especially in the Arctic and Antarctic, and that too, what is the problem of the ocean. See, if you look into the Arctic areas, this is your Arctic area, and you look at Antarctica, this is the average height of Antarctica. These are the real images, where on an average the shelves will be rising like a wall. Okay? Accessing of ships is not that easy here. Transportation is almost hurdled, only hardly a matter of month or so can be accessed. The research stations are also placed on this kind of plateaus. India has its own research station, this I have already shown. So imagine the height. So the movement and maneuvering is very, very difficult. Now just imagine of a concept called subglacial melting. देखो अगर पानी गर्म होता है ना, whenever the water gets heated, the heated water will always stay at the surface, right? The heated water will now get in contact with the ice here, and ice will not melt from the top, ice will be melting from the bottom as well. Now this bottom melting is called from the bottom because the sea water gets warmer by the heating. So because of that, the ice will start to melt from bottom also, ice will also melt from the top because from the sun rays and because of the carbon dioxide atmospheric temperatures. Now this type of melting from the underneath is called subglacial melting. So the report of the assessment report program says that on an average the rate of intensity of subglacial melting has increased. That means melting from the bottom of the ice, that means from the water, the contact area, the ice melting has increased. Because of this, subglacial melting also comes into picture, where it is also playing a major role in understanding the glacial melting process, right? Now same can be the case even for Himalayan regions as well. If the Himalayan regions are melting at a faster rate, that is an indication that this subglacial melting is also taking place, right? Now next, these are some of the reasons why it is happening, and finally let's take some tidbit questions. How exactly Arctic is different from Antarctica? देखो Arctic में there are some populations you will get to see, but in Antarctica hardly any population lies there. Only few people for research, they'll stay there, no population in the Antarctica. Now about the polar bears and penguins, in the most of the every class when I take up Arctic, I keep telling you polar bears are found in the North Pole and penguins are present in the South Pole. ठीक है? These two animals never met in their lifetime, and the annual average temperatures, Arctic has cold temperatures, but Antarctica जो है, it is the coldest part of the earth you will get to see here, right? So these are some of the tidbit facts. And last article for today is Godawari flows above danger mark in Telangana. देखो Godawari river has been in news for various reasons. So there are some areas for the past many years they have never been flooded, but now they are being flooded by the Godawari. So let's once look into the tributaries of Godawari, so because it has been in news for quite some time, and especially the area of Bhadra Chalam. ठीक है? There are areas which have been flooded by the Godawari, that is your Bhadra Chalam, Nanded, these are some of the areas. ठीक है? So the famous cities are Trimbakeshwar. In the origin, in the Western Ghats, it originates and it enters into the Bay of Bengal and drains into Bay of Bengal. It forms deltas in the KG basin, Krishna Godavari basin area. South here you will have Krishna river. This area is called KG basin and it is very, very famous for oil. ठीक है? Shale gas भी यहाँ पे it is estimated that shale gas is also present here. Now Bhadra Chalam in the recent times have been flooded and Basra has put on the high alert. Nanded, पानी का problem हमेशा होता ही है यहाँ पर. So these are some of the major areas the Godavari river is passing through. So now quickly let's look into the tributaries that are present here. Tributaries that are present here on the Godavari. So this is your Godavari river. Now let's quickly look into the tributaries. First one is Penaganga, next is Pranahita. ठीक है, Penaganga is the first tributary, next is Pranahita. See, Pranahita के लिए सब tributaries है और it has its own tributaries, that is Vardha and Vainganga. Vardha and Vainganga, they are not the direct tributaries. इससे पहले भी एक बार UPSC has confused on these lines. It is Pranahita, not the Vardha and Vainganga. They are also tributaries, but their tributaries do not come and join directly in the Godavari. Pranahita का tributaries है, and the other river is Indravati, Sabari. ठीक है, these are the major tributaries on the left bank. Now coming to the right bank, the major tributary is Manjira. ठीक है, Manjira river on which it has Nizam Sagar dam. ठीक है, Nizam Sagar एक काफी बड़ा डैम है गोदावरी रिवर पर. Now on this river you have a place called Bhadra Chalam. Bhadra Chalam is also the very famous area for Lord Rama, the temple city. It has been flooded and the relocation. Now the government of Telangana has said that 1000 crores will be given to relocate this particular area to a different place. That means people who are living in that coastal area. So it is considered to be a disaster. In that disaster relocation, a naya dimension has come into picture for our examination point of view. We should also look into that article, as I've already dealt with that article in the previous classes. I will not be going into that area. ठीक है, and a small announcement. See, a small announcement. It is, please make the best utilization of the Seize the Mains program, where the questions on these topics will be asked on the website, which is provided in the link will be provided in the description. So if you write your answers, our expert team will evaluate and send it back to you. Okay, so please make sure that you use this opportunity, because reading alone is not sufficient. Evaluation of your answers is also, that evaluation of your answers along with your standards, that is also plays a major role in your examination. That's it for today. We'll be coming and meeting on the next Saturday. Stay tuned, and for any updates on these articles, we'll always be updating you. Thank you guys for giving this opportunity. If you have any doubts, you can always message me with respect to these articles only. Okay, my contact number here is. So for any doubts, you can also mention your doubts in the comment section. We'll be addressing them, and if at all you have any doubts regarding these articles, you can also directly message me here, and my name is Madhusudan Reddy. Thank you guys, and see you next week.